Exactly.
Just show me some. Okay.
That's right. So I'm Rick Turnbull. I'm going to give you a introduction to using AI capabilities within XR and Unity. So if I look broadly at some of the general AI capabilities, now there are, of course, kind of niche models that have been trained for specific purposes, and also multimodal models that kind of stream vision and audio back and forth as well. But if we're looking at kind of the most sort of general popular ones, and they kind of fall into these categories, really moving through kind of vision capabilities from captioning, classification, detection, and segmentation. So if I exit this, I think RoboFlow have got a good little introduction to these kind of problem types, where you kind of start off with classification. So classification is largely if you have like a picture of a single object, then it can identify the object and give it a tag or a category. And then taking it a step further to give you localization. So here you get an outline, a location image, a bounding box where you can find it. Now I think with obviously with the camera, we are seeing more than just a single image, and there's obviously objects out there that we can't necessarily predict. So I think probably object detection and is something we are going to sort of talk about a lot later on. But this is kind of like one of the sort of core capabilities, if you like. It's basically the ability to detect multiple objects within an image, sometimes of the same type, provide you with a label, and also the bounding box and location. Now, if you kind of combine that with the capabilities of the camera, the Meta SDK, then using the depth APIs, you can actually locate these objects in 3D space as well. So it's kind of enhancing those kind of interactions. Kind of leveling up again, image segmentation is providing an outline or a mask for a particular object. So these are kind of things you see in image editing tools that are kind of removing and replacing objects, or like medical imagery, it's used quite a lot. These models are kind of, they are scaling up. So the simpler one obviously takes less CPU, runs a lot faster. It's not too complex to integrate, like through to sort of image segmentation, which is going to take a lot longer, can be more complex to work with. So ideally, you need to like identify the problem that you're trying to solve, and then pick the minimum model that's going to run at the right speed, and you can work with. I was going to show some of these capabilities. I think when you're exploring some of the models, there's a lot of playgrounds available from many other providers, and this is kind of RoboFlow's playground, and where you can actually sort of look at various capabilities and also test out kind of different models to compare them. So if we give it a go on a particular picture, then it'll execute them all together. Now, I think you need to take the speed with a pinch of salt a little bit, because this is kind of free. I don't think I'm logged in even. So the amount of CPU they're giving to playgrounds is probably quite limited. But nevertheless, you can kind of get the idea. Kind of GPT is giving me a briefer description than Gemini and the Claude models. I think sometimes Claude tends to be like critical of the photographer as well, quite interestingly. So you can kind of, you can look at the different kind of outputs that you might get from these models. I think the other thing is combined with kind of prompting as well. So sending an image and a prompt, you have capability to be able to like ask questions about an image, or prompt it more to be more brief and those kind of things. On the object detection side, if we ask it to identify coffee and a book, all these models are what we call zero-shot models. Now, Lucas is going to go into Florence a little bit later on, but the zero-shot models are essentially not trained on particular objects or specific objects, so not necessarily on coffee cups and books, but they can use some learning or thinking to be able to recognize objects that they haven't seen before, which means you can use them without specific training. Now, you'd have to bear in mind that they're not always the most accurate. You can see Claude Sonnet, he's kind of got it right, but it doesn't really have the bounding box is in the right place. And the Florence and YOLO World are like vision models, to be fair, and the Claude model is kind of has a general capability as well. I think one thing to note around some of these results, zoom in a bit, is this is kind of the response that you'll get back if you're calling AI over the web or over a hosted API. So you can see it's giving you the coordinates of the bounding box and a confidence score. So the confidence score is normally between 0 and 1. So it's 0.9 confident that that is a book, for example. So when you're building out these solutions, this is the kind of data that you're kind of interpreting and sending back and forth. I can quickly show you some others. And one thing to note on this, for example, you can upload your own images. So it could be worthwhile if you need to test things, taking cameras with the photos with a headset and uploading them and seeing what kind of responses that you get from some of these models. This is just kind of trying to identify individual objects. So if we go back to our capabilities, I have added pose detection in here just because it does come up quite a lot, and I think there's quite a lot of samples out there. It is kind of a more advanced sort of detection, and you can see this is Google Media Pipe, whereby it's kind of doing landmark detection. This is actually tracking over multiple frames in a live way, but it's giving wireframes for body parts and even facial recognition as well. So I don't think this is kind of running a Quest headset, but there's models that can do this kind of thing. Of course, you've got the Meta SDK for your own kind of pose detection, but if the camera's, looking at other people, you can try some of those capabilities. I think we're not really covering much around Gen AI, but nevertheless, there's obviously the models that you're probably aware of already around text to image and image to image. So you can kind of chain models together and read outputs from these and feed them into some generative AI to change filters and style, for example, and capabilities to actually grab individual images and create models and insert them into your scene at runtime as well. Can be quite effective. On the audio side, I think these capabilities have been around for quite a long time. The kind of text-to-speech is obvious. I think the OpenAI models are quite simple to use. So you're kind of passing in model text in a particular voice. So you can give like intonations as well as the actual voice options in here and the words to speak. So they can be quite effective. They've even got this playground as well. I don't think my audio is connected, so I can't play it. But you can kind of explore different prompts, give it more tones and information around the text as well. That's something else to explore. On the kind of speech to text side as well, as well as doing the actual speech to text mechanism, I think kind of linked into intent recognition kind of gives you the capability to take like audio instructions. So obviously, having keyboards to do text input isn't really desirable and isn't really too immersive. So like combining the speech to text with some of the intent capabilities, so a bit like your home assistant where you say, make the volume loud, turn the volume up, set the volume 10, it can sort of work out the intent from what you're trying to say and give you simple outputs like set volume 10 for each one. So you can kind of create more effective interactions with voice using intent recognition. On the tracking side, I wasn't going to go into this in too much detail because tracking, especially real-time tracking, is quite a challenge, but there are ways to use object detection to be able to do this effectively. So kind of having a marker or a QR code, so something unique within the scene that you can identify frame to frame. So any kind of moving object with that marker on there, you can use to actually track it. But quite a lot of the prototypes that you might have seen are using something called OpenCV, which unfortunately is quite an expensive paid-for asset in the asset store, and that kind of does native object tracking. So I think you can use these capabilities, but just be aware to do your research on what's out there. So if we move on from kind of the models and look at some of the providers, and these are kind of a combination of providers that we've investigated, and some of these form part of our validated kits that Nigel and Lucas are going to talk about later. I think obviously having OpenAI, as you might expect, is kind of an obvious one to have out there. There's kind of a rich set of models for you to explore, and these are kind of forming the foundations of ChatGPT. I can't use a playground because I need to be verified, so I can't explore these ones too much. But I think one of the advantages of the OpenAI models is that there's actually this open source package available. So this is maintained by OpenAI, but it's actually is kept up to date and integrates well with Unity. So it actually makes it easy to interact with some of the OpenAI models. If I kind of scroll down to look at some of the capabilities on here. So there's kind of looking for the speech one, create speech. So again, it's like just a few lines to actually create a speech request from the text and then grab the response back. And this is kind of not giving you like a audio clip, it's giving you like an audio a speech clip, like a native Unity object back. So like the integration using this is pretty smooth. And obviously the OpenAI models, we found quite responsive and reliable. Lucas is going to walk through some of the NVIDIA capabilities. So they've got plenty of sort of vision models to investigate. And as you might expect, I think we found that the NVIDIA ones are probably the fastest ones that we've seen, especially for like the hosted APIs. On the other side for RoboFlow, again, this is something that Nigel will explore in detail later. I think about RoboFlow, it's probably the best out there. So if you're not familiar with training, like data scientists train, then I think it's probably the most user-friendly way that you can actually train models on your own with a kind of little experience. And they have the extra advantages that the RoboFlow universe as well has got like an open source, like a community here. So if there's models available and somebody's already trained them, then quite often you can use these. Obviously, you need to make sure you need to test them correctly in the proper scene to make sure that you can validate them. I think RoboFlow's got a good kind of resource, and we'll explore that a bit more later on. Ultralytics is kind of the home of the YOLO models, which is like you only look once, and they have kind of a hub. I think the hub is kind of limited because there's a lot of the models on there are kind of paid for, but there's plenty of samples out there that take the YOLO models and run them on the headset, and I'm going to show you some of that in a minute. For Google, I think Gemini again is pretty powerful model, and there's plenty of options there to explore with Gemini, and the APIs are relatively easy to use. I think a word of warning on MediaPipe, which I was showing you before. So a lot of this is kind of about the SDKs available for Unity, and MediaPipe is kind of built for edge devices like Quest headsets, but I don't think they fully test the SDK for Quest. But we do know that it is possible to make it work, but there could be some technical challenges if you're trying to do kind of pose detection in real time with the headset. Grok is something we just added in here, something that we've kind of tried before, has the advantage that actually there's a free tier, so you can actually use Grok up to a certain limit before you need to sort of buy any credits. And like most of these, you will need to buy a certain amount of credits to use them, but it shouldn't be more than a few dollars really. But Grok got quite a good range, and if you want to try them out without having to pay in advance, then you can explore these, although we do know it can be a bit unpredictable sometimes with throttling. I think I need to mention Hugging Face. So like Hugging Face kind of on the surface feels like it's a bit of a goldmine of like models everywhere. And it's kind of like, well, I could just integrate these in quite easily. But kind of when kind of like looking around for some of these, the actual ones they host themselves are quite limited. And more or less, it's kind of a home for data scientists to share models and weights, and it's kind of a directory as well where you'll be sent off to other places. So there are great things within Hugging Face, but if you like want to try out sort of object detection via their hosted APIs, then some of the selections are quite limited. So next, I want to talk about like a simple kind of workflow about how you would typically integrate these models into Unity. So now, if you're running the camera and you're getting the pass-through camera access, this will appear as an individual frame as a webcam texture. So then you can grab this frame, then encode this so it's compressed into JPEG format, and then normally encode it again into base64 and send that through into a request, as I showed you before in the model comparisons for RoboFlow. So you kind of send in a JSON request over the link. And similarly, at the other side, you're retrieving that response, interpreting it, and then creating your Unity objects or sending it out as audio. And one of the advantages here is that the hosted APIs are kind of dealing with the complexity of calling the model themselves. So unless you're running it on the headset, you rarely need to worry about what an actual model input and output is. And also they're running this on their compute. So your headset's not concerned with, spending time executing the model as well. Generally, these requests are filtered for you. So you kind of get like a neat API to call directly, where a response comes back with like multiple bounding boxes or lots of confidence scores. Very often the provider will give you a kind of a neat way of working with it. And I've got a few examples I'll show in a minute of how to integrate these. And one thing to remember around calling like any of these APIs is that obviously you need to keep the scene running at all times. So you can't kind of like stop the world while the model is running. And that means using async or coroutines, basically running the model in the background or the request in the background whilst other tasks are carrying on. Now for like some of the hosted ones, that's quite easy because you're just sending a message and waiting for a response. And that's not really an intensive operation at all. It can easily run in the background. But if you're looking at running it on the headset, then you need to be more careful about how you share the resources. And again, I'll show that in a bit. So I'm going to just talk about a little bit about training and using YOLO as an example, and I kind of show you a view of what a model kind of looks like. So like YOLO 11 can do object detection and image segmentation. And there's various versions. I think 13 is the latest, and 14 will be out shortly. But 11 can do both of these things. Now, the thing to bear in mind around some of the models is that they're trained on particular data sets. So actually, this model is trained using the COCO dataset, which is 330,000 images and 200,000 with annotations, each of 80 objects. So if you kind of look at the type of things that have been labeled, so all these have been maybe manually labeled, and lots of people to create the bounding boxes, identify the particular objects, and then use this for training. So they're kind of sent through the model as a raw image compared to the expected result. If it's accurate or if inaccurate, you can send the model, tweak the settings, and send it back through again during the training phase. If you look at the type of objects that actually YOLO can detect, then there's like 80 altogether. So at the top few are kind of related to like traffic, so bicycle, traffic lights, a few wild animals, a few domestic animals, and then like random snowboards and surfboards. But there are some kind of, this might be usable depending what you're trying to do. So there are some objects that it can detect, like keyboards, mouse, laptop, and whereby it's possible that you could use this. But as Nigel's going to demonstrate later, you're better to like fine tune some of these models for the specific objects that you want it to recognize. And again, that will involve labeling the particular images yourself, and that's part of the training of the model. I did want to show kind of just what's going on a little bit underneath the covers when some of these models are running. Most of the time, you only need to really care about the inputs and outputs, and you don't really need to know what's going on here at the layers. It's like this model itself. This is the YOLO 11 model. So it takes an input image. It's like 640 by 640 RGB. So I was talking about the providers kind of deal with some of this. If you're using this model, then you're scaling down an image, sending pixels through, and then you need to interpret the response yourself. So this is actually returning 8,400 bounding boxes and coordinates, and then a confidence that each of the 80 objects is in there. So that needs sort of processing afterwards to create the bounding boxes and reduce the number to like the realistic ones that are in the scene. And I think bear in mind this is like a nano model as well. So if you're running on the headset, that like pretty much only the nano models, which are kind of less accurate, will work. And effectively the computation is running through multiple layers until kind of the output drops out the other end. So if you do encounter kind of Onyx models, or as models that you are intending to explore to run sort of on the headset, then just be aware that you'll need to kind of well understand how to interpret these inputs and outputs, unless you can find somebody who's already kind of tried it. And YOLO 11, YOLO 8 models, there are examples out there to explore. Okay, slideshow mode now. And just discussing the different integration methods. So I have kind of covered mostly the hosted APIs, and that's because really they are the most simplest ones to integrate. Again, they've got like well understood inputs and outputs, and there's a great range of models kind of out there for you. But obviously, they come with certain limits. I think one thing to bear in mind is, you know, even though you're getting certain credits, that you'll be subject to certain limits and throttling. It's tending that, you know, these are running on cloud providers, or like they're running on shared infrastructure, which you get a share of that, and then that will be limited if it gets busy. And then obviously the sort of more significant thing really is you have the connection, the network connection overhead, which can significantly slow it down. So even though the model is kind of executing, you know, pretty quickly on cloud infrastructure, the response is still not quick enough. And also it comes with usage costs as well. And most of the time you're paying for that. At the other end of the scale, there's kind of running the model on the headset, which gives you the benefit of, you know, being able to do things in real time. So you don't necessarily need to interpret all the inputs out directly. You know, you can feed it in real time and run much faster without any kind of integration in between. And that gives you the ability to run everything standalone, just purely on the headset. The kind of downside is kind of flip side again, it's that the integration can be quite complicated. And the inference engine is limited to Onyx models. So you might kind of find PyTorch models and TensorFlow models. All those need converting into Onyx to run on there. And most of the time you kind of need the nano versions of these that are built for edge devices, because the compute power on the headset just isn't powerful enough to run, you know, anything beyond the smaller models as well. And then you kind of get lag as well, because you're kind of doing the model, running the model and running your app at the same time. The local server option is kind of a really good sort of happy medium between these. And something Nigel is going to run through. I think this means you, instead of running the model on the web, then you run it locally on your machine, at your own machine. So you can sort of get the dedicated CPU or GPU power from your local machine. You can also, it comes with, like, you can find more niche models, and often the hosted providers like RoboFlow will give you sort of easy methods to run the same thing locally as well. Obviously the downside, again, you're not actually running everything purely on the headset. And it does require quite some setup. It varies depending on which provider you pick, but, you know, some Python knowledge, installing dependencies, working out how to build it. And sometimes they don't always come with web servers, so you need kind of to put a front end like Fast API on the front. So that there are some varying technical difficulties around running a local server, but it can be very fast. And so I have got some samples. I've got a very simple scene, which kind of quickly shows some of this. Kind of doing RoboFlow hosted and local. Let me just get out this a minute and share this scene. So I have a scene here. Fortunately, this person had a surfboard in their office for me to detect. Now, if we run YOLO Sentis, maybe the first time it's going to be 0.2 seconds. So you have to bear in mind that I am running this in Unity, so that the times even not going to be, you know, representative, but probably comparative. So YOLO can run relatively quickly, whereas if I try and run this against the hosted APIs on RoboFlow, then it is taking quite a significant length of time. I think it's also slightly less accurate. For the RoboFlow local one, so I download and install the server. So this is like running on the GPU on my machine. And if you kind of run this one, the first time, it kind of warms up, and then it kind of flies pretty well. I can show you just a little bit of the integration piece for this, just to explain what I had to show before about encoding. When I talk about encoding to JPEG and base64, I mean, really, within Unity, it's kind of taking a texture, one line of code to do the translation into JPEG or a PNG, and then another line to just convert that into a base 64 string. Here we're just kind of making a request. So this is posting the request in the format that's required. And kind of this is kind of the magic bit. We just kind of wait for a response from the API, at the other side whilst everything else is running. And then once the result's ready, grab the data, perform whatever we need to do. The RobotFlow one's is pretty good because actually the only difference between running this against the hosted API and the one that's running locally on my machine is changing the URL. So it's actually the same piece of code that can do both. So kind of, being able to work with these models is not too bad. If I compare that to kind of running something locally, then this is running the YOLO 11 model, effectively how it would run on the headset. Now, I showed you the diagram of the model before. If you kind of look at this inside Unity, you can actually see the layers here. It's kind of that was from the original diagram, and the inputs that it needs and the outputs that it has as well. But when we're running on the headset, you need to give it time to execute. So first of all, we're kind of converting it. So this is converting into the pixels into kind of the raw bytes so that you can see the 64, the 30, and the 3 to do this, and then scheduling it to run. And then once it's running, we're kind of monitoring it in the background. Now, what we're doing here is like we give each layer time to run. So in this case, layers per frame is set to, I think, 25. So effectively, each frame it's running through like one of those layers. So you can see that you can optimize this, but it can still take time to run fully end to end. And effectively, we can't do anything until this actually finishes. And then once it does finish, we're reading the request back from the model, waiting for this to come back. Same for the other output. So you kind of like the integration. It's slightly more involved. And then afterwards, then we get to the point where we can decode the box. And again, a bit of work, a bit of scaling on our side, trying to sort of minimize the number of boxes being replaced and being able to draw it. So really, like the key to the running things on the headset is kind of being able to understand the inputs and outputs cleanly and how quickly it can run. So yeah, I kind of rapidly run through some of those. I hope that was useful. I guess sort of the takeaways really are, trying to find the right model that suits your use case particularly, and then identify the correct providers and models, clearly understand the inputs and outputs, look around and balance in that cost, performance and accuracy. What can you live with? What's kind of the minimum that will do for your prototype to demonstrate the particular capability? So you're wary of spending like all your time trying to make a particular model work. And then looking at the integration method, if it works and the speed's not a problem, probably the easiest thing to do the hosted APIs. If you've got a little bit of Python knowledge, you can follow some of our validated kits. This is the optimal way to do things. Otherwise, try the inference engine, but beware that you might have to do a bit more work to get this going, and maybe the model might not be good. And again, kind of try, if a pre-trained model works for you, that's good, or a zero-shot model whereby you don't need to train it, but if you do, then fine-tune if necessary.
Perfect. Rick, ready to answer some questions?
Hello. I kind of ended abruptly. I wasn't prepared. Yeah, sure.
Yeah, we will share the links.
Yeah, I think I did see a question that accidentally
I have it. I
may
can
disappear
read it
around the speed of the YOLO 8 models.
When I tested, I can read it up.
Yeah, okay, if you read the question, I've lost it.
When I tested YOLO version 8 on HoloLens 2 some time ago, the frame rate dropped from 60 FPS down to 20-30, even lower during the detection. On Quest 3, what FPS are you seeing during real-time object detection recognition? Are you able to keep a stable frame rate while the model is running?
Good question. I think I can show this hopefully later if the video works. I'm not sure it'll come across as easy, but I think obviously the pass-through camera is running at like 30 FPS. So you're kind of trying to do the inference in between all those layers. Now that's competing for CPU time with whatever you're trying to show in the scene as well. So at the moment, yes, it is quite noticeable if you're moving around. Trying to track fast-moving objects is quite difficult with YOLO. So it depends what you kind of trying to use it for, I guess. It'd be acceptable, like if the headset's not moving around too quickly, but it is impacted quite a lot. I think it'd be interesting to try some proper optimization around some of the YOLO models, because when you install some of the Meta SDK, like all-in-one SDK, there's probably some unnecessary work going on that you're not actually using. So yeah, it's kind of similar. I think most of the models that run on inference engine on the headset can suffer from that.
Okay. I think we got another. Can you detect something, say a mug, and then add a tracker or similar to keep detecting it in movement?
Yes, so I think that's really the what OpenCV would do. That's the perfect sort of use case for OpenCV, which I mentioned in the video, is like the paid for asset. So like in order to get the speed, so you're not doing inference whilst the app's running, you can use object detection at first to locate the object, and then use one of the other techniques and the image to then track it. So you can detect it and then look at its color, or look at the shape and then track it from there. So if you're doing sort of real-time tracking, then using those, which are kind of more algorithmic based solutions, than using AI or quicker ways to do it.
Okay, perfect. I think those are all the questions, unless someone wants to ask. If not, then we can learn more
Okay.
about the workbench.
Yeah, kind of set myself up nicely for to talk about this now. This is kind of like part 2, I guess. Let me share a screen. Okay. Right. Okay. So share. With sound.
We have a quick question by share. Have you ever tried or compared with Vision Pro performance?
Vision, no, I haven't tried Vision Pro, like, at all. Yeah. I haven't tried that, no.
Okay, we see your screen default. Oh,
Did you see that?
one more question. The local server is personal or commercial with payment?
So no, I think so like RoboFlow, Ultralytics, and others. I think even the Hugging Face ones now as well. You can just download their Python package, like the Python inference package, and then it will basically transfer the model locally. I think you need to be logged into RoboFlow to get access to the model, and then run that. But after that, there's use. But I think, I think commercial use for some of these models can get quite complicated, I think, as well. But I think for development purposes, you can use them, but then they've all got different commercial agreements if you go beyond that, as far as I know.
Yeah. Okay, let's start now.
Yeah, okay, cool. Okay, so yes, I'm going to run through the workbench. If you just run through the agenda. So effectively, sort of based on the previous talk, really, where I was exploring different providers and different workflows, and you saw the 2D app, I kind of tried to standardize the way that I'm building and interacting with some of these models to try and make it easier to test them out. So the workbench kind of started off as a bit of a test harness to make sure that, we were validating these things on the headset. But also it's kind of a bit of a playground as well for different workflows. So I can show you the workbench itself and walk through that, and then explain some of the providers and the workflows that are built in at the moment. Run through some of the components, so it's like a modular kind of build, which I can show you that. Try a live demo. Fingers crossed. I have a video if that doesn't work out, but I'm hoping it does. And then we can just walk through how you can reuse some of these workflows in your own prototypes, kind of outside the workbench. And then I'll finish off with some bit of limitations around the current use and some things that I'm looking to do to remediate that. And
Are you sharing the right screen? We see folder.
Do you see this screen?
Yeah, with the folder. I thought you wanted to show some video.
All right, 1 second. All right. Share. Screen 2. Share. No? Do you see the slide?
Yes. Yes, perfect.
All right, okay. I'm sorry you were staring at my folder.
I thought some video was coming.
But there you go. This is kind of the things I was talking about. But fortunately, I don't have to talk about it. So Gabriele Romagnoli kind of posted this on his LinkedIn. I'm sure you won't mind if we share it. It's just a quick 50-second video. Did I share with sound? I think I did. Just demonstrating some of the capabilities. So I'll just play this. It's got a cool car and a cool soundtrack. I need to full screen it or not? Okay, so that's kind of set the scene, I hope, for kind of what the workbench capabilities are. So, going back to what I was talking about before around the various capabilities that are out there. So the workbench is kind of designed to do single kind of request response workflows, where there's, one type sent and one received. So each one is kind of single shot. It's like image to text, text to image, back again, those kind of things. So there are obviously a lot of the models that are used can do multimodal. So they can send and receive both image and text as well. But in order to kind of simplify the design, it's kind of on purpose that I've designed it to do one thing at a time. And in fact, some of the models appear multiple times with very similar requests under different categories. So the first three are more like on the generative AI side. So I've used Stability AI for the image to 3D, which is the stable, fast 3D model, which will give you an object that you can put into the scene from an image. I've tried some other ones, Triple AI as well, which in the future I will probably add in, but it has a more complex API to work with. And so at the moment, the Stability AI is just the one that's in there, but it's pretty quick actually and has good results. I think text to image kind of standard, generating images from text prompts. The image to image workflow is there. I think my intention was to kind of try and change the style of an image or try and get AI to do some clever things with it. But when I was using the OpenAI API, I realized it was actually for image completion. So like for phone apps where you cut out a segment of a photograph and then send it to AI to fill that in. And then when I did the same with a transparent image, it worked. So at the moment, the image to image one's quite limited, but I think that workflow has lots of opportunity to add more interesting things into it. Object detection, there's lots of examples in there of different types of object detection. Lots of the ones that I showed earlier, from hosted inference, local inference, running on the headset, zero-shot models as well. And I think the main thing I'll show later is that, so the idea around the workbench and the APIs is to try and standardize the results that come back from the model. So especially with object detection, you get different bounding boxes in their own coordinate space. And like in order to be useful kind of in Unity or for XR, then you need it in the Unity coordinate space. So the workbench and the back end kind of standardize some of those interactions to make it more easy to manage each of the models. Image to text, capturing images or identifying a list of objects that might be in an image, and then we've got speech to text, text to speech ones as well. There is some support in the back end for text to text. So I've tried some of those models running on the headset, but at the moment it's not in the workbench, only because it needs some thought around, how to do chat really, because it's more of a keyboard interaction at the moment. But yeah, those are the key ones that are kind of hard coded into the workbench right now. Again, kind of seen these before, and I've added some indicative costs in here, but please don't hold me to it. Please check before you subscribe to some of the models that need paying for. Some of them are per request. Some of them will depend on the number of tokens, so the size of an image sent or received. Others are free, but then rate limited, and then others you need kind of tokens and subscription. So yeah, check those out before you perhaps sign up to some of these models. But you can go a very long way in development, just using the free APIs, as long as you're not hammering them like all the time. Yeah, so I've got the stability AI in there as described. And I think also the OpenAI one. So when Velen was talking about the way that he'd integrated AI into his project, and that's using Raging Against a Pixel GitHub repo, which I mentioned earlier. It makes it quite easy to integrate with OpenAI, and it's got multiple workflows built in. So in this case, it's using the DALL-E models for the image workflows, and then TTS and Whisper one models for speech inference. The Gemini Flash models, again, you can use some of these for like development as well. You can get quite a long way with the Gemini Flash models. The image model actually needs you to sign up first before you can use it. But yeah, I think the Gemini model is like multimodal model. I think I might have the temperature set wrong because it seems to be super creative compared to the other ones that are running the workbench. So we'll see how that goes. And then YOLO, already talked about. So YOLO 11 is in the workbench, so I can show that running in the headset as well. And then we've got Grok and NVIDIA, which have got free access with like lots of models at the back end. I think NVIDIA, especially, there's lots more to explore on that side as well. And then RoboFlow. So I can show the RoboFlow, but really Nigel's kit is the best one to use if you're intending to sort of train your own models using images from the headset. Check out the kit that Nigel's done, because it also gives you the depth API to locate things in 3D space, and it's a much kind of richer implementation. But it's in the workbench anyway. So just to compare it really with the others. And the last part is there's some plugins for using AWS. So some of the AWS services support some native integration around, speech to text, text to speech, and image recognition already. So they have native services. And then Bedrock is their generative AI platform, whereby you call in standard APIs, and then at the back end you can talk to Anthropic and their own models and some of those. So that's been integrated recently with a lighter weight SDK. So if you're familiar with AWS, there's normally large SDKs you need to deploy, but this is kind of a lighter weight version to make it run more quickly. So just walk through the bits and pieces that make up the workbench, and hopefully I can share some of the code. So yeah, sort of describe the workbench itself. Let me open. Sorry. Can I get to? I'm still sharing.
Yes.
Yeah, you can see the See the Workbench repo? Yeah.
Yes.
So the Workbench is the front end that you've seen already. So this is available. The links are in the presentation and that we're sharing shortly. Anyway, so when you install this, the only thing you need to do really is use the secrets manager to add various plugins. So if you have API keys already, you can add them all in. Otherwise, you might have to subscribe. So if the moment if you don't put the API key in, then obviously it will break because it's a minimum kind of requirement. But in order to get up and running, you can run this in Unity and update the secrets, and away you go. Hopefully, just I guess the core part really is this package. So the Workbench uses this accelerator package underneath. With the idea to standardize those interfaces. So here you're seeing these again, and this has got these plugins built in already. So if you install this package, you don't need a Workbench. You can just install this into your XR projects, then it will automatically come with these plugins featured. There needs some dependencies to install for the OpenAI bits and pieces as well. And then you can use a secrets manager for your own secrets. So obviously make sure that this file does not end up in Git to protect your API keys. If you look at this, some simple docs here, which shows how you can call these workflows. So most of them follow a pattern. So you would initialize once, pass in any options for that particular provider or model, and then execute many times. So image to text, takes a 2D texture that you've grabbed from the scene, and then this callback will be sent when it's ready. And this is all running asynchronously. So the scene carries on, you send it to the interface, and then wait the result, and then you can process this result yourself. And then you can see the pattern. So you initialize, a text goes in, a texture comes back out. Now, what this means is that if we're investigating different models, then all we need to do is implement the plugins themselves to meet the interface, and then they're just called the same way. So if I show you quickly one of the plugins. So this is holding the NVIDIA implementation that's using Meta Llama, and there's metadata embedded in the code, which then drives the user interface underneath. So like this implementation has got the provider name and then multiple options that you can call. Now all of them have defaults, which means that if you just call them with your API key, then it should work straight away. But if you need to fine tune some of the options that are sent, like you can reduce the quality of the JPEG image to make it smaller, or you could try different image sizes to make it faster, and play with the temperature and those kind of things. So depending on the model and the provider that's in there, then there's different options, but it's kind of built into this accelerator. There's also a few kind of helper functions. Sorry, just find the doc. There's some helper functions as well to manage bounding boxes, factory to receive to do the lookups, some object detection helper classes as well to assist. I can show this in Unity in a minute. Yeah, so I think that plugin architecture means, for example, that the AWS one is now in its own Unity package. So if the if the Workbench is installed and the accelerator is installed, you'll get those default plugins. But unless you install this package, then none of the AWS plugins will appear. So these are kind of like separate. So I think ideally I would start pulling out some of those plugins into their own repos just to stop all the dependencies piling up. But at the moment, this is one standalone plugin that does all the AWS stuff. So I think with those kind of components, it means that the Workbench can now build itself because based on what plugins are installed, it knows that which ones they implement to do the buttons. It knows all the model options to put in there. And then, when we're looking at new models, I don't need to worry too much about a UI anymore because it's kind of a ready-made UI for those defined workflows. I did cheat a bit by adding image icons as well. I think I need an icon feature so you can embed that in your plugin, but that's the only cheating bit. Okay, so look at the project itself. So if you pull this into, can you see my Unity screen? You can. So when you install this into, I don't know why I'm not getting like a share thing appearing. So yeah, if you install the project into Unity, we're on what 6002.10 F1 at the moment. Then largely you just see kind of like the UI. So thanks to Maria Tam, who's done some great work on improving this UI after my prototype. It's got lots of satisfactory buttons to press now. So we have the UI, but also there's a component that you can add. So this is part of the accelerator, not the workbench. And it actually gives you like an inspector. So based on the metadata, it generates panels so you can see the different options here. So in here, you could save them in here, and then it will just work when you run it or build it based on the default properties. I wouldn't necessarily change the models or the URLs because things will probably break, especially as the plugins are designed based on certain request formats and responses, and sometimes different models give different formats as well. But in some cases, you can change some of the llama models and some of those as well. And just a note on the secrets manager. So in resources, this will be here already. This file won't exist. So this is the one that's not in GitHub, but the secrets manager can be used to add, your API keys into here. The AWS ones are kind of named after the workflow name. These are all the same kind of keys, but there's information in the GitHub repo if you need to look at that. Okay, I think maybe we'll just try and see if we can run it. So let me find my screencast. Now I might have to do, ideally we need to share audio as well. So what I need to do is if I start casting to the web. Okay, I hope that's working. Now, if I turn this up and then mic off, let me turn the volume up. It's quite hard to see with the headset on. Okay, can you still hear me okay?
There's a little echo, but
yeah, I'll turn that down. Hopefully that's better. Can I make this full screen? Yeah. Okay. I won't be able to hear you now, so I've turned down the echo. Turn a little bit more. Okay. So we're casting and the workbench. Now it always starts to my right because I'm not on the side of the desk.
Rick, the echo is pretty bad.
Is it really bad?
Yeah, when you start talking faster, it gets pretty bad.
Okay. So let me do this for now. If I kind of talk like this,
yeah,
for now.
No, it's fine.
Okay, I'll do without the audio, and then for the audio bits, I'll have to switch it on and try it. I'll try and stay close to the microphone. So yeah, let me know if this isn't working out. So yeah, essentially you can see all the workflows. So these are all built from the ones that are installed. Object detection is getting quite long as well. Now I kind of need an image to start with. So with the left hand, I've got like a capability to just produce some test images. So like the first one is an office with objects to detect. It actually looks like it's AI generated itself, to be honest. I hope my lighting was good. Yeah. So like the back plane lights up when it's attached, it should snap into place. Now it should be able to try some basic like object detection. I did notice about an hour ago that Google Gemini was having big problems. So I might skip that and try and do that at the end. But if we try YOLO, so I think someone was asking before around how quick this runs. I think for a single detection, it might not be obvious, but I can try. So now, the headset, when it initialized, wasn't very responsive. But you can see it's kind of detected those core objects in the scene and outlined them as well. So if I try RoboFlow, so RoboFlow is working across the internet on their hosted API, and it actually uses the same YOLO model. So, I mean, YOLO did 1.3. So the second time, it's normally quicker because it's warmed up. If I try RoboFlow remote, then again, I think at the other end, it takes a little bit of time to warm up. But the inference has taken a bit longer. And also, I think it uses the same model, but the confidence scores are lower because it filtered out some of the other objects in there. So the recognition, Amazon Recognition 1, seems very fast for a hosted API as well, although it's come back with kind of less objects that have been detected. Again, that might be to do with the confidence score. Recognition key points does facial detection, and there's no faces in here, so it won't come up with anything like that. And I don't currently have a local inference model running locally to do the comparison, but yeah, normally it would have that running and then you can test that. And I think at the moment I'll do Google Gemini last, just in case. So that's with like static images. There's also got a kind of test video as well. Some problems catching it. So this looks like a object detection for like CCTV cameras. There's like people walking through. Now, if I do YOLO, you can see it's kind of the UI is going a bit shaky. I don't know if it comes across on the video. It's kind of interfering a little bit with it. But it's kind of it's catching up quite well, considering that also, I'm kind of getting the bounding boxes and displaying them in between. I don't know, it sometimes says cat, person as well, and chair. So like, I think that image is quite dark. So at the moment, each one of these object detections runs for about 30 seconds. So we missed the person running through there. Hope you can see this okay. So if I try like RoboFlow, so that now this is kind of sending a RoboFlow request each time. And then it's taking like a second or two on each frame. So a lot of the time, actually there's not a lot in here, but it's not doing a bad job of catching up, but then, it stalls every now and again. So that's going to run for a few more seconds. So yeah, you can see that, we can try out different models, different plugins based on the same kind of UI. Now, if I close that one, my hand seems to stay over there. If we try kind of image to text again, let's just put this one back. And then I'll kind of run the NVIDIA one for now. So like this is coming back with, so at the moment, the UI, some of these responses come back and they're very long. So the UI kind of cuts them off at the minute, but you kind of get the idea that it's functioning correctly, and it's coming back with, you know, a description of what's in the image. I think the other thing, so one of the things you can do now with the pass-through camera is also use that to sort of take photos, hopefully. This is going to be quite dark, but you can kind of see what I see. And then we can have bedrock. Hopefully that's going to come through. Computer screen, multiple monitors. So let me put that back. And then maybe we can just try and create an image out of that. Yeah, so it's fairly quick. That's way better than mine already. I mean, I'm going to try the Google one to see if it works. I do wonder what it's going to come back with. We'll see. Okay, that's cool as well. So yeah, so you can see there's like multiple workflows in here. Right. So that hand catching thing. So if we try some speech to text, so I kind of want to generate something, I can try. Now what happens here is it'll record audio for 5 seconds and then capture all the audio, send it to the model, receive the response back, and then play that back. So it's not optimized for streaming. So there's quite a bit of a delay. We'll try it and see if it happens. Cartoon of a ninja wearing a VR headset. Yeah, so that actually did stream back sort of like word by word. Now, you're not going to hear this, unfortunately, at the moment. I mean, I could try. Hope everybody's still with me.
Yes.
Right.
Hear you.
All right, I will try just this a minute. Oh.
Cartoon of a ninja wearing a VR headset.
Cartoon of a ninja wearing a VR headset.
So yeah, so you can see you did that. Now I can also, well, didn't mean to do that. It's like this is kind of the equivalent of the inspector that you saw in the Unity editor, whereby you can kind of dynamically change some of these settings and try and run the model again as well. So this part only works like, do this. This part only works in the headset because the keyboard doesn't work in the editor. So if I change the voice to like Alex, okay, right. There's no validation, so if I spell that wrong, it's not going to work. Close that.
Cartoon of a ninja wearing a VR headset.
So yes, so you can see that you know, you can dynamically kind of change things like on the fly. So if we get a good image, then we can try the image to 3D one as well. Come on. Okay. Let's try Google. Not quite wearing one. I think the image generation worked fine. Okay, this one's good. So if we try and run the 3D inference and stability AI is playing well, then it should take the image and filter out the border and give us a cool. It's pretty good. Stick them on my desk. Yes, I think those really, I think I've covered most of the workflows there. I did want to sort of demonstrate one final part that I haven't published yet, but I've been working on OpenAI real-time integration. You might not hear the responses, but I think the text comes up. Hey, Sensei, are you there?
Hey, I'm right here. How can I help you today?
Open text to image. Open image to text. Run NVIDIA. So
All set and ready. If you need any more help or want to try something else, just let me.
I knew that happened. I knew I'd start talking whilst the AI was responding to me. We'd start chatting back. But that's just an example of using some streaming with some of the tools. So that's something to investigate later. So I think we're all good. Let me quit. Okay. Right, is everybody still with me?
Yes.
Thank you, Laura. Whoops. Oh, I'm sorry. Oh, okay. Yeah. So in order to sort of reuse some of these, then, you can, this is the basic kind of calling method. So once it's plugged in, then you can just load the particular provider by name, the resource name, and then initialize once. So always initialize in a core routine, passing in the API key. So once that's done once, then you can kind of run this multiple times, again, in a core routine as well. So you kind of execute with the prompt and then just wait until the task is complete, and then you get the result, and then you can do what you need to do with it. And that's generally, it's in the documentation, so kind of standard pattern that if you need to sort of just use the accelerator, not with the workbench, then you can do that. So yeah, I don't want to write too much of a long list of limitations, but I think some things are obvious, especially around that object detection. At the moment, there's no kind of depth API helpers in there, so it's just working with like 2D images. So I think along with the practicalities of kind of streaming the camera into the workbench whilst you're looking at the workbench and then doing object detection, I think there's some UI work to do there. And I think obviously enhancements around some of the request responses, try and add some WebSockets, some streaming in there as well, and come up with some UI for conversational LMs to try those out a bit more. And I think really I'm testing it in the workbench most of the time. And it's not quite battle hardened. I imagine trying to use it in different scenarios, they might come into trouble. And it's just me trying to look after it and support it. But if you do use it for your prototype and you come across issues, then the mentors around. You can put on Discord where I can respond, or you can add an issue to the repo. Maybe we can get some fixes in there as well. But I think what's next, I think fixing some of those outstanding things I've talking about, try and build out more providers. I think the workbench is getting quite big at the moment, so looking at that, doing more multimodal support as well, so to do both. I think it lends itself quite easily to doing some of those. And then the main thing is trying to just investigate and add more providers and plugins. And I think some more interesting workflows are there around text to video, image segmentation as well, being able to remove parts and fill them in to try some of those models out as well. I think one key thing, of course, is that Meta are introducing their AI building block soon. I haven't seen much of that yet, but it looks like a kind of similar thing where you can add building blocks for different providers into your project, which sounds great. And I think potentially some of the plugins that are there already might work with this and be reusable in that way. So kind of the middle part can come out, but we're yet to see what that looks like. And these are the links that I was showing you earlier as well. So if you want to give it a try, then these will take you to the GitHub pages. I think that is me.
Amazing.
Right. Phew.
As Farhan
Oh,
said
that
it
was all right.
before.
I can't tell. It's quite hard to tell whilst I'm immersed.
Yeah. But as Farhan said, let's stop waiting and let's implement it today with this workbench.
Sorry, what's waiting and what's implemented today?
The meta AI blocks that they teased during the Connect.
Yeah, exactly. We don't know, right? What's the why wait?
Waiting.
Why wait?
We have a few questions. We can get to them. If you create Quest app that use AI with subscription model, you sell the app and stop paying subscription. Is there a way to manage payment one time? Is there other solutions to use AI permanently in an app? Thanks.
Yeah, I imagine multiple different ways depending on all those providers. I think, even if you kind of say, well, I'm going to run this model on the headset, that if you kind of then sell your app and it's part of the app, then there's commercial terms to meet. So even if it's not hosted and you're just using a particular model, you need to check the commercial terms. But I think, a lot of the providers have already kind of tackled this. So you can get special API keys that are for apps that you can kind of distribute on app stores that are safe for particular usage as well. So I haven't got specific examples, but I think it's a known problem. But there'll be terms attached to that. So you're not kind of sharing your personal API key. There's app specific ones that you can use.
Another option in between is using AI-powered workflows like N8N or make
Yes.
to activate automations. Any thoughts on that?
Yes, that sounds interesting, I think, because what became apparent, which wasn't really on purpose, and I mentioned, which is actually, you can see and kind of connecting the workflows together to produce like a different pipeline, if you like. So I think it kind of, it could lend itself to basically, picking each one up and creating sort of these connections and then setting that as a pipeline to do it. So I think, it's an interesting, like N8N, it's an interesting thing to look into, I think, yeah.
Amazing. They said amazing. I hope you see that. Okay, two more, I think. Is it possible to train a model on personal content and then to create experience replicas of them in one's XR setup? And then I think you should look up this Q&A and then recognize their advice in public spaces or by locating them externally as a cognitive hacker. And then to hijack their XR experiences by learning about their sentiments and producing painful or scary experiences for them, or the opposite, to train resilience. Or how can a person create a shield for themselves to protect themselves against manipulative gamified XR experiences? Ooh.
I need to unpack that a little bit. So training model on personal content and then creating replicas of them. I think at the moment, recognize their devices and then hijack by learning about their sentiments. Is it painful for them, opposite, or how can? So is this like a privacy concern around sort of the models being trained on personal content and somebody grabbing that content and then using it against you? I think this is kind of similar. I'm assuming that's what it's about. And I think it's kind of similar to the question that came up earlier about, the privacy concerns about sending the data, your screenshots to various models is a complex issue, you know, because if you're streaming your headset, your computer or whatever, then there's terms and conditions around what happens to that data and where it goes. But yeah, I think just generally with AI, right, there's lots of kind of safety concerns, I guess.
I'm not sure how well you need to train a model to be able to detect like personal things.
Yeah, I
Besides
mean, to the
faces.
simple answer to the question is you can train the model to recognize objects around the room in your space. If you take photographs with a headset, I mean, it's exactly what Nigel demonstrated, what the kit does with RoboFlow. So you can do that. But kind of using all the rest of it is quite complex, I think.
Okay. Then they would like to see the QR codes again.
Oh,
And if you can share.
you got them?
And the recording, in the meantime, can say will be shared with anyone who signed up to the same email that you used to sign up for the event.
Share
I
screen.
I predict the workbench is going to be the most used resource to build in the hack.
Lots of people to debug that. Well, that's nice.
I think it's amazing that you can take a workflow and it actually, if you count it up, it's 18 workflows for each provider and 7 types of workflows like text to image and stuff.
Yeah, I think really the aim will be to try different types as well, because a lot of them providers host the same models, so it kind of feels kind of the same thing. But there's two aspects. One is the provider interface, and then the other one is the model that's behind that and what it's used. But I think, you know, trying out different patterns of calling these models, like I showed in the OpenAI real-time one at the end as well. Has everybody got this? Okay. I think
We have one more question.
okay.
Especially with generative AI, now also generating academic research, it can target humans as experimental participants of AI human behavioral hypothesis. So yeah, that's to the previous question.
Okay.
Yeah, about privacy. Yeah.
Yeah. Okay. Yeah. Thank you. I think I was going to quickly mention around MCP. Should I do that?
Sure.
Your MCP server.
And then we can finish with the kits.
Yeah. So only a few days ago, the Meta announced their MCP servers. So if you are using some agents, coding agents, then as part of the latest MetaQuest developer hub, so under the settings and AI tools, you can integrate the MCP servers into VS Code or manually through different IDEs, depending on what you're using. So I've yet to try this, but it kind of means that, you know, inside the agent instructions, that it will use Meta's documentation to answer queries in the background. And it also has some cool features here, as well as the documentation. It can kind of fetch logs from the device as well. So if you're kind of getting it to troubleshoot for you, it can kind of take screenshots and look at the logs, and it looks pretty cool, I think. So well worth checking this out, I think.
One more question. We leave no question behind. Are there communities building AR XR capabilities on top of Flutter apps? Our main application is in Flutter, but needs to access headsets SDKs. Any suggestion how we should do the integration?
I'm not familiar with Flutter. Sorry, do you?
Me neither.
Oh.
I mean,
If anybody else can help out with that one. No, I'm sorry, I'm not familiar with Flutter.
I'm not sure how much you can access the headsets SDK outside.
Yeah, okay. We can check that out.
Okay, then let's move to the last part. I see no more questions.
All right. Cheers. All right. Thank you.
Thank you, Rick. Amazing. Let's dive right into the AI kits that we mentioned already a few times. Let's do that.